Hello.
Hi.
Hi there.
Let's wait for a few minutes. Maybe somebody will join.
Andre, you're on mute.
Sorry for that. I post a link to this document. Welcome everyone on our bi-weekly community meeting, developing Cozystack. Please put your names into attendees list. I'll repeat that we have Telegram group at Cozystack. We have Slack channel in official Kubernetes Slack. We probably do not have any new members on this call, so let's switch to, oh, that's a wrong one. Okay, should be here. Let's switch to agenda, and today I would like to introduce the new version of Cozystack. Thanks, Nick, for writing such a cool changelog. This version is introduced GPU support for tenant Kubernetes clusters. Lately, we were in CNCF webinar and explained how it works, how to configure Cozystack cluster to use GPU, and there were an example how we run stable diffusion. Also, we got community contribution from Zdenek, who contributed Gateway API option for tenant Kubernetes clusters. We started working on cross-architecture builds and actually adding support of RAM. Currently, it is in beta. For now, it is in the phase when we're preparing runners, and I think the next version will also support RAM fully. Thank you, Nikita, for such community contribution. Also, we did some enhancements for vertical port autoscaler. We added it for Cozy dashboard, etcd operator, and also tenant Kubernetes control planes. We introduced additional Helm release reconciliation controller because we found that we need to have some additional logic for FluxCD, which will make dependencies between the Helm releases and to run the proper reconciliation between them. That means that you can update your Cozystack configuration file, and the rest and all the releases will be forcefully reconciled. Or if you update hostname in your tenant application, all the dependent Helm releases also will be reconciled. We also slightly updated virtual machines. First, we introduced the configuration for static CPU placement. That's more about configuring Talos Linux. added feature for downloading virtual machines from Kubernetes. Actually, just draw the interface for it in Cozystack config map, and start supporting various storage classes. There were some tweaks about supporting not only linstore, but various storages. We also changed the virtual machine application to not enable all IP services by default. So by default, the only 22 port will be exposed. And there were a lot of bug fixes. Right now, we just found that we still have some problems with Thales 1.10. So I think we'll roll back it soon and implement the support of new Thales in the next release. The set of components get updated. One of the most interested is linstore here, because linstore started supporting ZFS snapshots properly. Now it can remove them, can create. So if you have chain of snapshots, you can remove the snapshots which get which stored in the between inside of this chain. Also some tweaks for KubeVM. Now it becomes more stable. Yeah, thank you, Kingdom, for updating Flux CD operator. And also we updated cluster API and a lot of related things. Actually, tenant Kubernetes clusters also get updated. There were a lot of changes about health checks. So for now, it should be more stable. We introduced also new framework for testing. Now it has BATS compatible format. So it is possible to run specific tests manually. But it is not BATS itself. It actually just uses its format. And it provides better output. So if you'll take a look at our pipelines, you'll see a lot of new green emojis, hopefully green, not red ones. So for now, we have better output for testing, for our testing suite. And many changes for CI/CD process. We decided to introduce also building of alpha and beta versions before we start creating release candidates. That's probably it. Thank you, everyone who participated in performing this release, contributing features to us. That's actually it. Yeah, and I just wanted to repeat that there is a GPU demo and CNCF webinar which get published. You can find it in this link. And let's switch to OpenFloor. So for now, we are working on adding AirGap support, and we found that there are few components which are depending on external artifacts. The first one is Flux CD operator. And there is also cluster API operator. Both of them are looking for OC artifacts in external repositories. And we were thinking about how can we organize that. So the first option would be to move, to provide the configuration. How can you repush your images? Yeah, cool. Thank you. Kingdom, please send it to new PR. I think it will be in your release already. So we need to think how can we repush those artifacts to AirGap environment, which usually have some Nexus or Harbor server, or we can also consider running registry server inside of the Cozystack, which will hold all of these artifacts in read-only mode and configure Fluxity operator to download artifacts right from it. Do you have any thoughts on that?
So I thought about that, about both ways. So about a year ago, I even made a pull request about AirGap support, AirGap installation support. From my side, it looks better to make a way to repush images, but it takes a lot of time and a lot of work. And it is a bit, it has some unclear steps how it could be implemented. So I think it is a good start to make the second approach work for now, just for fellows who need AirGap installations right now. And then proceed with the first approach, where all images are somehow gathered and somehow repushed to an external repo. I would go with that.
Yeah, you would need to do that anyway, that's true. So we could consider using some global configuration file for all right, yeah, I have an idea. So we can use our existing building approach, which will take these images and store it in a repository, and then just record the values into the Cozystack application. We use this approach for Cilium, I think, and for Kubernetes. Like we can just create dummy Docker files, which will look like this. We have it in Kubernetes.
Yeah, like in a single, it will contain a single from statement, and you just Docker build from this Docker file. Just like that.
Yeah. And they can be repushed as part of any other images. Yeah, that makes sense. Thanks for an idea. I think that's a correct way for solving this. And
actually,
I'm not sure.
during my investigation, I found out that Scopio can copy images from repository to repository. So maybe Docker files would not be needed, and we can just run a set of commands to copy images from external repository to some internal one, or to some tar files or something, or archives.
That's also an option. How can we go? I like the existing approach with having single file Docker file for them, because you can use normal buildings for building everything. Existing approach like or will.
Well, since you want to have all of our images in 3, I guess we're planning to do that anyway eventually.
Yeah. The good question is how to make them, because creating Docker files for all of them could create, it might be difficult to set up it for all the components, but finally I think it should be done that way. Otherwise, you would never know which images do you use, and you still have external dependencies, which I really don't like. That might be insecure from the security perspective. So we would need to consider adding all Docker files for all the images we have. Not sure how many of them. At least we just need to have this understanding.
So there's a couple of things I want to mention. Not all OCI repos are Docker repos, so I'm not sure if the Docker build strategy will work the way that it's described. I would definitely test that first. Obviously, you're going to test it, but the next question I have is how do we handle provenance then when we move? Because I know a lot of these things are using cosign to provide signatures. Can we make some kind of build process where we validate that signature and then create a new signature in the target repo? Because I think those signatures are actually tied to the repo. So whoever's doing an AirGap is going to want to have their own key that they can validate those images against, or a copy of the original key, or both.
Yeah, that makes sense. I think we can sign all the images with our own key. So if we download image from the upstream as part of normal Docker file, we can sign it using buildX syntaxes. I think it should work with no troubles. So anytime when you create new images, new Cozystack release, it can be built from that way and also sign the images. Some images also, yeah, that's good that you mentioned that not all of the images built that way. For now, we have Alice Linux also compiled as part of Cozystack, and it uses its own builder instead of the Docker buildX.
It might still work because it's pulling a manifest that's a regular OCI manifest, and the layers all have metadata, which should come along. So it might just work, but it's worth thinking about. We
Yeah,
might use
yeah.
a tool like Crane instead of trying to rebuild so that it's just identically the same image, so signature would validate.
Also, there are tools which allows you to repush images with existing signature. I guess Crane and Scopio should be able to do that. At least they don't change digest. So when you download image from one digest and push it to another, the digest isn't changed, which is pretty good. And I think it also can handle those signatures. Don't know. We probably need to investigate it more. Thank you for your thoughts. All right. I also would like to ask if what is the RAM support for now? I saw there is some issue from you, Nikita.
Yeah, so I found out that there are more Docker images that may not have ARM versions. Not this one. This is the ready pull request and is in issues, not on pull requests. It is something like more images or something. No. Search issues tab, please.
All right, cool.
So all those images don't have ARM versions, and I already checked how it could be solved. So some images we need to rebuild because there are no updates to them or something, and some of them are just can be just updated to the latest versions, and it will. I wrote that I'm not sure about KubeVirt because KubeVirt support for ARM is quite limited, and I'm not sure if it needs to be implemented right now.
Interesting. What is not supported in KubeVirt for RM?
I just found out. I just found a page on KubeVirt site, and they write that a lot of stuff is not supported for ARM.
This is supported, or yeah, all unsupported virtual machine configurations in different steps. Very interesting. So we probably, the only thing we use here is Numa, huge pages. And
So
host
I feel like
pathing.
virtualization on ARM should be investigated before implementing conversion support. And I am really not sure if virtualization is that much needed, because
Yeah,
from my perspective, ARM instances are usually Raspberry Pi or something, those kind of hardware, and they don't need virtual machines to be running on them. So maybe we can delay and investigate it separately.
yeah, and I think that also could be solved later when we will decompose Cozystack to various configurations. So in case if you want to get it installed in RAM, you can just not enable virtualization and infrastructure as a service bundle.
Yeah, sure.
So the only bundle for PaaS services will be available. We can even create a separate bundle just for RM, and handle only applications should be installed there as a workaround for now until we have proper separation for this. Or we can start creating a bundle for RM in separate repository and also change Cozystack to make it connectable, like create some empty bundle in Cozystack right now, and in instruction for installing RM, so we can consider moving it into separate repository.
Maybe, okay. So one more thing about virtualization is that to properly test it, we would need a bare metal node, really a large one on ARM, and it is quite a quest to find something like that. Maybe some clouds have it, but I'm not sure.
Yeah, we have access to Oracle Cloud provided us by CNCF, so we can create a RM virtual machine there.
And maybe one more thing about runners. I just tested GitHub runners, which GitHub provides for free. And they work surprisingly well, and they're surprisingly powerful. And I think for now, we will need the runners only to run E2E tests, and we can build all images and like run some tests or maybe some stuff like that, just on GitHub runners, not utilizing Oracle infrastructure.
I have a worry that it does not support nested virtualization, but we just decided that we don't need virtualization at all. Yeah, we can try. I have worries about building multi-arch images because as far as I know, Docker buildings needs to have access. If you want to create multi-arch image, you need to build both architectures with single command.
Actually, I tried building it on different runners, and during push, it just assembles a manifest which contains both architectures.
So you can do that separately.
Yeah, I believe so. So currently, I am trying to write a GitHub workflow, which will just run a simple Docker file, which will just build a simple Docker file on two separate instances with two separate architectures. And I will have results at the end of this day. I can report something.
Right, Timothy has a hand raised.
Yeah, I was building multi-arch images at another job, and it's nice if you have a buildX builder that builds them in one command. But even if that is not available, there's plenty of tooling for that. So there's this manifest tool which can download 2 or however many versions of your image and then push it with a unified manifest. And really, the main reason we didn't initially go down that route is to keep our build scripts more or less uniform. So someone who is running on ARM could use the same commands as we do to build it for ARM. Someone on x86 would build them as usual. And if someone has a builder configured for multiple architectures, he can build images with multi-arch support right out of the box. But if we're willing to make some more complicated scripts to handle that, yeah, I mean, why not?
I don't like complication. I think the best option would be to use native buildings opportunity to build both type of images. That might also work worse in case of if we run testing, it will just take more time to build both images. Maybe it's not a problem. Actually, I don't know.
Yeah, that would be great if we take the time to set up our build infrastructures to have at least both architectures. And I also, won't be so quick to dismiss virtualization on AirGap. There's plenty of hardware being sold right now, like actual servers on Ampere with AirGap architectures. And when I was deploying stuff in AWS, we quite quickly migrated to Graviton instances because they simply turned out to be cheaper and more performant than their x86 counterparts.
Makes sense. Makes sense.
Yeah, I agree that ARM instances are widely accessible, but I'm not sure about virtualization for those instances. So I already used them, but just as instances, not as the host machines for virtual machines.
So I think the solution to this would be to create a few virtual machines which will support building of AMD and RAM, and also single machine. All right, I have an idea. So we can create few runners, for example, 2 for AMD and 2 for RAM, and configure both to use AMD and RAM builders. Like you can configure buildings to use SSH to build another architecture. So in this way, we can have, if we build AMD on AMD runner, it will build locally, and if you build RAM, it will go to another runner, which is running as a neighbor to this one. I have some ideas.
That's what I use at home right now. So I have local runner on my notebook and a remote runner on a desktop machine, which runs a virtual machine with the runner. So it works perfectly, yes.
Not sure how complicated it would be. I'll try to prepare such environment. Right now I'm reconfiguring runners. I think that will be solved soon. Well, thank you for your ideas. I'll try to create a single interface to use same buildx command. The only question I have for now is how it get know on which architecture it is building right now. Is it any auto detection in our Docker files or?
Yes. So there are a couple of arguments which Docker buildx passes into context, such as target arch and target os. You can check my pull request. There are plenty of examples. And I just add those arch and os arguments into go build string, and it works okay.
It was.
One more thing, and for now, in common env's makefile, there is a kind of after detection. There is a kind of after detection, which platform to use and which builder to use. So if you specify builder, a platform gets after calculated, and every variable in a makefile is getting replaced with that.
All right, got it.
And if you specify, you can not specify a builder, it would be auto detected as a default, and it will just run on what you have.
Okay, thank you for explanation.
Maybe we can check after detection. I can explain how it works a little bit.
Yes, do you want to present, or I just need to open this file?
I think you can open my pull request and just find some Docker file there. Like packages, maybe something.
Let me just find your pull request.
It is in open. Oh, no, it is in open. Cross arch builds core installer, for example.
Or should I open a previous one?
Oh yeah, previous one is definitely better. We can check some files changed. Yeah, MetalLB would be nice. It also has those variables set. So see, each makefile now contains builder and platform arguments on these lines, yes, which got after calculated. And inside the Docker file, this one would be unmodified, but we can also check it. Just a Docker file in the So see on line 8 and 9, there are arguments which Docker buildix passes inside the context. And depending on those arguments, they are being set to the go command, go build command, like on line 30. So it just sets go auth, go arch, and runs go build command with those arguments. And that's how it works.
Thank you. So buildix automatically appends those arguments into building process, even if you don't specify them explicitly. Cool. Thank you for noticing about this. Okay. Do we have any other questions to discuss? In this way, going once, going twice, and see you in 2 weeks. Thank you for attending Cozystack community meeting. Bye-bye.
Bye, everyone.
Thank you.
Bye.
Bye-bye.